But the narrative in 2017 was really along the lines that Ethereum particularly was going to bank the unbanked. I paid $1,000 for a Uniswap transfer during DeFi summer. And at that point in time, I was like, all right, this is not the future of France.
If you are an Empire listener, hopefully you've played around on chain. And if you have done that, you know that transferring assets across different chains is a pain, to put it nicely. That is why we are incredibly excited to have the Wormhole Foundation as a partner of the Empire podcast, stewards of the Wormhole protocol, supporting over 30 different blockchains and 6 different runtimes. Stay tuned. Later in the show, we have a cool thing that you can claim, which is a Wormhole NFT just for Empire listeners. This episode is brought to you by PayPal. Here at Empire, you know that Santi and I are really into real-world use cases and always on the lookout for the next killer blockchain app. We're excited to share that PayPal has arrived in crypto to unveil a way to seamlessly connect fiat to digital currencies. Later in the show, you will find out how you can use PYUSD to check out at millions of online stores. What's up, everyone? Before we jump into the episode, little plug for Digital Asset Summit coming up in London, March 18th to 20th. Tickets are pacing so far ahead of schedule that we had to decrease the discount code. So instead of Empire 20, it is now Empire 10. Head over to the website, Digital Asset Summit, DAS London, March 18th to 20th. Use code Empire 10 and get 10% off your ticket. See you in London. All right, everyone. Welcome back to another special episode of Empire. Today we've got Logan Jastremski. That is the Americanized version of Jastremski here from Frictionless Capital. Logan, welcome to the show, man.
Well, thank you so much, guys. Really looking forward to talking and excited to be on the other side of the mic.
Yeah, pumped for this. Okay, so other side of the mic. That's a good place to start, actually. When I first met you, you were running around like a chicken with your head cut off, basically with this huge backpack that I think you'd spent like $10,000. You taken your savings from your time at Tesla, and you're like, I believe the world works this way, and everybody believes something different. Everybody believes that the EVM is the end all be all, and we're going to scale with L2s. And I believe that they're wrong. And I'm going to go create a podcast that and a fund on the back of this thesis. And so I think Santi and I both want to get your thesis on Celestia and Move and Solana, and you've been ridiculously right about a lot of these things. But actually, it would be helpful as a starting place to just hear what is Logan's mental model and framework for like how you view what blockchains are supposed to do.
I mean, it's a great starting point. That time in New York was funny. I've gotten very efficient at recording podcasts on the go, but I think for me, I just wanted the industry to scale. I got involved in 2017 within the crypto markets during that bull market. Ultimately, kept with it throughout the bear market and got really excited during DeFi summer, as a lot of others did, with kind of the idea of composability and these permissionless smart contracts. But the narrative in 2017 was really along the lines that Ethereum particularly was going to bank the unbanked. And I paid $1,000 for a Uniswap transfer during DeFi summer. And at that point in time, I was like, all right, this is not the future of France. Like, why are fees so expensive? And really just started exploring different avenues. And I think from my time at Tesla, it was really kind of beaten into me. Like, think from first principles, boil things down to their fundamental primitives and build from there, like question assumptions. And all I saw throughout kind of my time in blockchain, like even today, it's really just kind of bag bias. It's like, hey, my bags are better than your bags because I have a bigger bag, or no one's really able to like articulate why these things actually work. Like kind of from a engineering point of view. And all I was really trying to do in my journey has been establish kind of base primitives that can be comparative across the industry, which ultimately led me kind of down the high throughput blockchain rabbit hole. And once I kind of went down that route, it was hard for me to look another way. And so I've been saying that the same things for 2 years, that high throughput blockchains are going to bring mass adoption to crypto. And I still believe that today. And ultimately, we started Frictionless Capital with the thesis that these blockchains are not 2x or 5x difference in performance. It's quite literally 100x, if not 1,000x difference.
So I'd be remiss not to say that every cycle we have the competing L1 trade. I'm hearing you say this time is different. I've have the benefit of having talked to you over a better part of a couple months. Maybe walk us through that journey. You know, which when you say high throughput, are you talking about Solana, Aptos, Say, Sui? What are they able to achieve that Ethereum has fallen short in their vision of scalability? And what are some of the more important breakthroughs that you've appreciated in this journey?
I ultimately realized that you're going to hit the limitations of these systems. Like I like to think of like, all right, you push each of these systems to 100% capacity. What does that look like? And then how do you further scale from there? And what I really realized was even if you use layer twos, which I kind of view as like data compression, you're compressing data down to use the block space of the L1 more efficiently. Eventually, even if you use 100% of the block space for the L1, for with layer twos, you still at the end of the day are going to have to increase the amount of block space. And this is ultimately Ethereum's roadmap and what they're working towards with 4844. It's not a meaningful amount kind of compared to high throughput blockchains. They're adding like 0.375 megabytes, which in the grand scheme is not that much, but meaningful amount for Ethereum. And then ultimately scaling with dank sharding down the line, which is a couple years away. And for me, what I really realize for all these systems is you really have to scale the amount of data. And this is kind of what is happening in the current narrative with like Celestia, Eigenlayer, scaling data availability layers as the core bottleneck to all these blockchains. And once I kind of realized this, I ultimately just started going down the rabbit hole of what do these differentiated ecosystems look like and how are they actually, to your point, Santiago, different than Ethereum. And so what I've come to appreciate is truly the fundamental differentiation between all these ecosystems is just how much is the hardware going to cost. I think my point of view on kind of like full nodes is the physics has to happen, whether that happens on the layer one, that happens on the layer two. If you want to do compute on layer two, that's fine. If you want to do it integrated into L1, that's fine. If you want to offload data availability to Eigenlayer or Celestia, that's fine as well. But you have to do the physics. You have to have high throughput blockchains, and eventually you're going to have high computation in some form or fashion. You can move those pieces around, but you can't eliminate them. And so when I started really going down and exploring this more and more, I was kind of just fascinated by how do these actually work from the product perspective and the engineering perspective. And to me, it just made a lot of sense to integrate them together. You don't have the liquidity fragmentation, you don't have the confusing UX that kind of layer twos have. And the more that you can kind of simplify that user experience and developer experience, it made a lot of sense. But there's a couple key trade offs, or not trade offs, but a couple key properties to me that are really different from kind of the Ethereum killers of the past. One, that's being high throughput. So you're doing a lot of data availability. And then the second component of that being parallel processing, and happy to dive into both of those.
Yeah, maybe parallelization is something that has come to light and is very much a buzzy term right now. So could you
Yo,
simplistically talk about what that actually means and
sure.
who have this feature and which blockchains don't?
So the Ethereum virtual machine was ultimately really innovative at the time because it allowed kind of Turing completeness and the ability to build smart contracts on top of Ethereum, which was not possible really at the time with Bitcoin. And during that process, though, it was a relatively simple virtual machine. It executes transactions sequentially, just meaning one after another. So if I send you, Santiago, $10, but my brother wants to send my mother $10 simultaneously, even though those transactions have no relation to each other, they have to be executed one after another. But and that's one obviously fairly low. It's much harder to do that from it's more simplistic from an engineering point of view, but it's harder to scale throughput in that way because you're always doing transactions one after another. Solana was ultimately the first blockchain to do parallel processing. It enables you to really, one, do more transactions per second because you can, instead of doing all transactions sequentially, if they're not overlapping or non-contentious pieces of state, you can do them in parallel. One that massively increases the amount of throughput or transactions per second that you can do on the network. And secondly, what it allows you to do is to isolate fees to specific applications. You can think of like more granular fees than like what exists in, say, the Ethereum virtual machine. Uh, in the Ethereum world, you have, say, the Bored Ape Yacht Club Mint happening. A bunch of people are trying to get access to that state, but I want to do a Uniswap transfer. And because everybody wants to get access to the Bored Ape Yacht Club Mint, it is making my Uniswap transfer very expensive. Everything on Ethereum spikes, even layer twos, because they use, or most of Ethereum, most layer twos because they use the Ethereum virtual machine. What Solana ultimately enabled and why it had some downtime was it started with parallel processing, but soon after the fact figured out it need to localize these fees to specific applications because they're using more resources. And you only increment that specific application for slightly higher fees. And ultimately, what this enables is multiple applications in like a single ecosystem. Uh, it's one, a much better user experience, and two, it's much easier for engineers just on like resource pricing. It
Mhm.
allows multiple applications to live in a single ecosystem, which is like a massive breakthrough.
Yeah. I want to stop there because before I continue down this optimistic and like like parallelization, there's two different kinds, my understanding. Like, why did Ethereum in its initial state didn't consider parallelization? Was there some sort of research breakthrough or technical upgrade that was possible?
I no, I mean, parallel processing has been like kind of like low hanging fruit or like best practices, I think, since like 2010. Ultimately, engineers figured out that it's going to be harder to add more transistors to a chip. So every year you see Apple come out with its new silicon. It goes from 12 nanometers to 8 to 4 and 2. And eventually you're going to hit the limits of physics where you literally cannot add any more transistors to a single chip. And so the way that they increase compute capacity is add more chips or more cores. So they've rewritten, and this has been kind of the best practices for the last 10 years or so, to for software to take advantage of multiple cores, and you spread out the workload on these additional cores. And it wasn't
Mhm.
like some unique thing per se that Solana came up with. I think it was just perhaps Anatoly kind of having a background in like high performance computing at Qualcomm that allowed him to like identify this. Now Sui does this, Aptos does this. Monad's big thing is we're going to parallelize the Ethereum virtual machine. Um,
Yeah.
but again, this is some of the limitations with even L2s because L2s do not really, they haven't innovated on the virtual machine design. And so they're kind of taking the worst parts of Ethereum virtual machine and bringing that to layer twos. And so, I mean, when Arbitrum was doing their token drop, you saw fee spikes to, I think, like $5, $10. Base, you've seen their fee spike. So, like, I'm very curious how these L2s are going to adapt over time that have adopted the Ethereum virtual machine because they're going to run into the same limitations that the Ethereum did.
Yeah. We talk about this idea of could Ethereum implement some of these new like um, technical features. The component that we constantly, and the term that I think we hear is backwards compatibility. Like, how is it possible for Ethereum to upgrade to and become a parallelize the EVM? You talk about Monad. Are you aware of Ethereum at some point throughout the last so many years thinking about this, and maybe it's not just possible to do it?
I think there has been EIP that allows developers to specify trans what state they're going to touch within the Ethereum ecosystem. But and that's like a great next step, but I think there's issues around being able to do the localized fees. It's really parallel processing enables two big things, which are ultimately today nice to have, but in the future going to be mandatory. That is unlocking additional throughput by going from sequential processing to parallel processing, and then unlocking global fee markets to localized fee markets. Both of those to me are paramount for really future scale. I don't know if Ethereum, from your point, Santiago, if it's going to have some backwards compatibility or not. If it, I think honestly, I mean, if it were super easy, Monad wouldn't probably exist. Monad has really started up because some of the limitations of Ethereum, keeping some of that backwards compatibility with Ethereum, but making it high throughput and parallelized.
Logan, if I had to try to summarize this conversation up until this point, let me try to do it just to kind of get
Of
my
course.
my mind around your thesis. Basically, it's you believe blockchain should be built to scale, but fees are preventing that. Fees are driven by two factors: block space and state contention.
Yep.
On the block space side, Ethereum blocks are very, very small. 4844 increases the size, and then Dang sharding will increase the size a little more. But when you compare it to something like Solana or something else, it's still maybe 1/100th of the size. So that's
Yep.
block space, and then state contention um, is that's where like this parallel idea of parallelization comes in. Is that kind of like so that's when you basically say, all right, we need a new solution. I know you've been really excited about Solana, and now you're starting to get excited about other things. Is that kind of a fair assumption of your thesis today?
Yeah, I mean, at the end of the day, there's a massive difference if fees are $10 versus $5 versus 50 cents versus 5 cents versus uh, a thousandth of a cent. Like the types of applications that you can make are fundamentally different and allow different levels of scale. And I think the unfortunate thing about kind of the Ethereum ecosystem thus far is any application that has started to achieve some levels of product market fit kind of has anti-network effects where the network and the application actually get worse the larger scale it becomes. And so all I've really why I started looking at alternative systems was because I thought crypto was relatively niche. We're still, I mean, if you look at daily active addresses, which may not be the best metrics, but is some proxy to activity on chain, these are generally measured in hundreds of thousands of like daily active addresses, not hundreds of millions.
Right.
And when you compare that to Web2, it's just a fraction. And I think if we really want the industry to go to mass adoption, scale is the number one thing that has been limiting us and engineers. And I think once you kind of go from this dial up of Ethereum world to broadband and then fiber optics, you can build new applications like YouTube to the equivalent of Web 2 that you could build on high throughput blockchains. And I think that is why we're so excited about what is happening in these high throughput ecosystems, really Solana
Mhm.
taking off, the newer chains coming as well. But there's really fundamentally new applications that are unlocked that are not possible on these low throughput chains because of the limitations that you described.
Um, you mentioned something that I think is a key property, I think, which is this idea that for the most part, every blockchain we've seen has struggled from anti-network effects, right? The more users that want to do a particular activity at any given point in time, you're ultimately competing for block space that has a spike in fees and that degrades the experience. Um, you mentioned, network effects and how that could be possible. What are the big unlocks that enable that? Is it like local fee markets and who actually has that? Because I think we talk about like this idea of localizing fees, but my understanding is even Solana, like it's still very much in development and hasn't been fully implemented. So can you just walk us through kind of the what network effects look like in which kind of blockchain can we will be able to see that and what are the like breakthroughs that enable that.
I do think it's a combination of being able to have more granular fees over time. So like resource pricing of the network. At the end of the day, this is a shared network and there's not an infinite amount of resources. And so the more granular that you can be in that resource pricing, the better. I mean, just because Ethereum was first and kind of the early adopter for this, I think they kind of took a basic point of view. But today, because of that, you have these kind of global resource pricing, which just makes it hard for any one. If one application hits scale on Ethereum or an EVM L2, you start to suffer these anti-network effects. And so to your question, it really is like one being able to granularize fees to kind of be more granular on resource pricing over time, and then increasing the block space. And I think both of those kind of have to be done in tandem. And this is um, maybe it would get down to the debate of like how big of nodes should be and like the differences between Celestia and Solana. But I think in terms of answering your question on like network effects, I really think it's just like the more state, so like more people care about things that are going on in blockchains, the more valuable that state becomes. So it's really like where are the users going and where are the engineers going, which is kind of cliche. But I think these new blockchains, and why I've always been more excited about high throughput chains than kind of the Ethereum or low throughput chains of the world, was because scale is a requirement, unless you want to stay niche. And so to me, Ethereum kind of optimized for the incorrect thing with keeping hardware relatively low and focusing on like profitability before hitting scale, where these high throughput blockchains have focused on scale. And then once you hit scale, you can eventually get profitability.
Logan, your initial conclusion to this was Solana, but now there's a lot of other folks on the market. So there's Celestia approaching this from the data availability perspective. There's Monad, who's kind of rebuilding the virtual machine. There are Aptos and Sui. There's Say, obviously. What has been your like evolution of V1 is okay, Solana solves a lot of this stuff. Excited about Solana. V2 is what?
I don't know if there's V2, and that's the kind of hard part. All of these blockchains are now kind of writing the software to take advantages of increasing bandwidth and increasing kind of parallel processing. So when you add more bandwidth to the network or more block space, the network, you don't have to rewrite that every time that happens. If you go from 100 megabytes to 200 megabytes, the network should automatically know, hey, I can ingest more data and send more data out. Same with kind of adding more cores to the network. And all these new blockchains are kind of slight variations of what Solana is kind of like first stated of, hey, we're going to increase throughput and we're going to increase computation. But these are not, I mean, 10x improvements over Solana. Going from Ethereum to a Solana enable parallel processing and doing high throughput was quite literally 100x in like performance design. These newer networks are slight optimizations in either how they do parallel processing, how they come to a consensus, and more optimizations than like massive leaps in terms of this is a network is fundamentally that much better.
Maybe this would be a good time to go into the two different types of parallelization, right? Deterministic and optimistic. And, I think, as I understand it, those are probably the biggest distinctions between Solana, Sui, Monad, Aptos, say, like,
Yep. So yeah, in these different networks, you can do parallel processing differently. Solana and Sui both do deterministic parallel processing. All that means is you have to, as an engineer, you have to state which contracts you're going to interact with ahead of time. And it's kind of annoying from an engineering perspective because it puts more work on the engineer to do this. But ultimately, what the result is you know ahead of time if if you're going to be conflicting in transactions. The conflicting transactions are super important to know because that's when you need to know, hey, Jason, you really want this MEV trade versus me. You're going to actually bid more than me. And because of that, you're going to have to pay slightly more to get access to that. And by having the engineers state which contracts they're interacting with, you're going to know ahead of time if you're going to be able to have these be processed in parallel or if you're going to have that state contention. SWI or Aptos, Say, and Monad all do optimistic parallel execution. They kind of push the problem from the engineer down to the virtual machine level, where it's a little bit more engineering friendly because they don't have to state those dependencies. But what they'll do generally is run all the transactions like they would have been run in parallel and try to. So some of them will run, some of them will not run. Obviously, there's going to be some conflicting transactions. And for those that do conflict, they have to rerun those again. So there's slight differences in one, the performance, and two, kind of the user experience. I think the more interesting thing is with optimistic parallel execution, if you're not always knowing whether you're going to have state contention or not, there may be some variable in fees that may be a little bit more onerous on the users than, say, the approach that SWI and Solana are taking, which is deterministic.
When I just to round out this, when I first heard this distinction, I felt that deterministic was a superior design long term. While you are burning engineers, I think just mechanically, I just feel like that's a more elegant solution, and one that would allow you to really discriminate conflicting transactions and focus on that and optimize fees.
Optimistic parallel execution will only ever be as good as deterministic.
Right.
So deterministic, like even, I mean, it's nice to have optimistic because engineers don't have to think about it and it's handled by software. Deterministic is really nice because that's the best possible performance you have because you know whether things are going to conflict or not. The things that don't conflict, you can just do in parallel, and those are fairly trivial. But optimistic, the best case you can get the performance to is deterministic. So yes, deterministic is nice from the performance standpoint and user standpoint because you always know how much fees are, but it's a little bit more onerous on engineers.
We could keep going down other features of blockchains, consensus
we're getting
algorithms
nerdy.
and whatnot.
Well, can I ask one more
just go-
question? Go ahead, Santi.
No, I was going to transition, but I want to, maybe you go first.
I have one more question on parallelization, Logan, which is, what do you think about folks who are bringing parallelization to the ETH rollup ecosystem? Like folks like, maybe
Eclipse
what
or movement.
Yeah, like what Neil is doing at Eclipse and folks like that.
You're still bottlenecked, even if you, funny enough, I think they're the best L2s because
you think the best L2s are the rollups that are basically leveraging something like the SVM, you're saying?
Because they do localize fee markets. You have to localize fees because today, even Coinbase is fantastic, has been a great champion for the industry. They don't have localized fees on Base. So if Friendtech comes roaring back and they start scaling, Friendtech is going to be the single driver of fees in the entirety of Base, and all other applications built on Base will suffer. And that's true for Optimism, that's true for Arbitrism, that's true for Polygon. All the ones that have copy and pasted the Ethereum virtual machine as it stands today will suffer from those issues. So you have the same anti-network effects that you had on Ethereum. You have to be able to localize fees. And this is why Eclipse and Movement have really, I think, leapfrogged them, despite you don't have kind of the backwards compatibility with Ethereum, and engineers have to rewrite their smart contracts, which is really, in my mind, the only downside, which it is a big downside, just to be honest, because you have to rewrite your app. Like that takes quite a bit of time. But just moving the virtual machine to a Ethereum of the world, you're still limited by the block space. So because there's not that much block space on Ethereum. Eventually you're going to hit that capacity limit and then fees will spike. And so this is why generally Ethereum is viewed as the settlement layer instead of the data availability layer, because you're going to both need to scale throughput and you're going to need to scale computation, which these newer virtual machines do with parallel processing. But again, you can't obfuscate the physics. Like if you want, you need high throughput. Ethereum, if they don't want to do that at the base layer, that's fine. Arbitrum Nova will do it. Eigenlayer will do it. Celestial will do it. But that throughput has to happen. You can't do low throughput and scale. Same for the virtual machine. You're going to need high compute. If you want to integrate that, totally fine. If you want to put that on a layer 2, also fine. But the physics has to happen. You can't get around the physics of scaling these things.
I remember seeing a great chart that you have, and maybe we'll link to it. But just give us a sense of perspective of on a relative like scale, like Ethereum, some of the L2s, like where do you start reaching that endpoint and limitation? And how does that compare to a next gen blockchain and then Solana in its current state, Solana with Firedancer, just to give people a rough sense? Because every time I talk to an L2 or a project, it's like, well, I don't get the sense that many understand what that limitation will be.
Yeah.
But I think you've done a lot of work on that, on kind of really spreading that comp, if you will.
Was it this one, Santi?
This one's a little bit old, but yes.
Yeah.
So
Yeah, but, you know,
what I would love to do is create like a API that ultimately could pull some of these things, but this is directionally kind of correct. So Ethereum today does 80 kilobyte blocks. There is 1,000 kilobytes and 1 megabyte. There is 1,000 megabytes and 1 gigabyte, and there is 1,000 gigabytes and 1 terabyte. Just for everybody's reference. So every time you go from 1 megabyte to or 1 kilobyte to 1 megabyte, it's 1,000x. It's a little bit hard to understand these things because the numbers are just vastly different. But Ethereum today is relatively small. What 4844 is going to do is add 0.375 megabytes per block, but the block times are every 12 seconds. Ultimately, Dang sharding, which will ship in 2025 or 2026, will be 1.3 megabytes per second, as you see here. Celestia, they're today, I believe, doing 8 megabyte blocks every 12 seconds. So these numbers kind of change. Eigenlayer is targeting 15 megabytes per second, and Solana today is doing 40 megabyte blocks every 400 milliseconds. So the difference, again, between Ethereum and these high throughput blockchains is massive. Like, I don't think we would have started frictionless capital if it was a 2x or a 3x difference. It is quite literally 100x, if not 1,000x. Solana Firedancer target, if you go to their page, they've shown them doing 25 gigabit transactions per second on 4 cores. And they have a plan to scale that to 100 gigabytes or gigabit. So I kind of think in long term, these systems do end up closer resembling kind of like high frequency trading, where you're ingesting hundreds of gigabytes per second, parsing that, and then doing execution on it, than what most people believe is like the ZK version of the world.
So when I look at this, and assuming Firedancer is coming later this year, I've heard Anatoly talk about targeting breakpoint, which would be in September. But I mean, it puts it at a whole like order of magnitude and a half or so relative to even next gen blockchains.
People don't
So
realize the difference. It's massive.
yeah, so 2 questions. One is translate the megabytes per second to
Normal
usage,
speak.
you know,
Um,
because I've heard Anatoly say the question would be like, does Firedancer, like, can we get Visa, can we get NASDAQ on the
yeah.
blockchain with Firedancer? Does that have like, I want to give people like a practical sense of what these numbers
So
actually mean.
Firedancer was demonstrating 600,000 transactions per second, I think on 10 gigabit. And Visa currently at its peak, I believe, is doing 65,000 transactions per second. I think it's more steady state around like 2 to 5,000, if I remember correctly. So, I mean, there's a lot of headroom in these systems. I think the biggest takeaway that people should get from this conversation is you can't get around physics. Like, if you want to move data availability layers to somewhere else, fine. If you want to move compute somewhere else, totally fine. But you still have to do it. And if you know that, then it's integrating or coming to the decision of how do you want that user experience to be? Do you want to integrate them or do you want to modularize them? I think the integrated approach is much cleaner. I think it concentrates liquidity. I think it removes the fragmentation. You don't have Arbitrum USDC and Optimism USDC and Base USDC. And fundamentally, I think it's just much better. But it's massive in difference of performance.
I've started asking teams with this question, which is, why would you build on anywhere else? Like, why not just build on Solana? If you understand this fired answer, if you believe that's going to happen, why even bother looking at and building anywhere else? At some point, you know.
I mean, we can get into like the differences between like Celestia and Solana or like Sui and Solana. There are some differences and trade-offs in like how the approaches things, but at the end of the day, the high compute and high bandwidth are going to be requirements. I just don't think engineers fully appreciate this and how large of a difference these blockchain systems actually are. And I think it will really take one kind of breakout consumer application to kick off that flywheel. But I think it's happening. I mean, to me, Solana really reminds me of what happened in 2018 with Ethereum, where all the Bitcoin people were dancing on Ethereum's grave at that point in time because they're like, it's only used for Ponzi's, it's for ICOs, it's never coming back, and Bitcoin's the holy grail. And obviously, the engineers that stuck around with it on that time, I mean, are now legends. The Aves, the Stani, Compound, Robert, like those guys are OGs in the space because they stuck around and kept building. And I think Solana was in a similar position post FTX, post all the downtime with the bugs that it had. The people that stuck around believe in the technology and understand the difference in performance. And now it's not the copy projects of Ethereum, so to speak. They're really innovating on how do I build high performance blockchain applications because you have a new sandbox to play in. And I think that's what we're excited about at Frictionless Capital is these new 0 to 1 applications that are only possible on high throughput blockchains.
Logan, if you're wrong about this thesis, why will you be wrong?
I try to ask myself this. I really have a hard time articulating the bullish side of kind of an Ethereum of the world. And I really try because the goal, Santi recently
Well,
had a
there's
good
two
tweet.
buckets. It's not just Ethereum. There's like, in my mind, there's kind of three buckets that you're laying out. There's kind of Ethereum, which is still has 90% of the mind share, 90% of the developers, 90% of the liquidity. Like, we got to remember that. So there's Ethereum.
Is it though?
The developer report, I think, had Ethereum or Electric Capital's developer report was like 3,500 or 4,000 engineers in the Ethereum ecosystem that were full time. I think Solana was at 500. So it's not like a 10x or 20x.
Maybe it's not 90%, but let's go. It's 7 to 1, whatever. And you get what I'm saying, which is the overwhelming mind share and number of people are still in Ethereum land. So there's bucket number 1 is Ethereum scaling with L2s, whether it's ZK Sync or Polygon or Arbitrum or Optimism. Bucket number 2 is where the thesis has been planted, which is Solana. Bucket number 3 is what I'd call like new cycle, new things like Celestia, Eclipse, Monad, Sui, Aptos, Say, like that bucket as well, which, you know, maybe some still use the UVM, but like they're new experiments.
So like the ZK of like worldview, you're doing, I view layer 2s as data compression and new execution environments. You've created a new execution environment. You're still going to have state contention. I mean, most likely because multiple applications are going to live in that network. So eventually people will bid the fees up to that economic value within that layer 2. So you generally have similar prices as what you would at the layer 1, but I kind of view them more as like data compression. You're batching a certain amount of data and posting that somewhere else, which is totally fine. You can do that. But again, because you're doing data compression, you want to really post your data, in my point of view, on the blockchain that has the most data to compress. Like going back to that chart that Frictionless Capital published, Ethereum is a very low throughput blockchain. And there are newer blockchains like Solana that do much higher throughput. If you want to use a layer two, totally fine, but you want to use layer twos or data compression on the chains that have the most data to compress. You can't infinitely compress data. You can do like a ZK proof of a ZK proof. Like you can recursively do these things, but at the end of the day, it's kind of like one app chain to another. There's like real world latencies that you can't like abstract. It gets very messy. It's like, is my Uniswap pool on this shard or this shard? And like trying to communicate across all of them is a little, it's not super clean. So
Yeah.
I'm very
I
skeptical of that worldview.
Yeah. Maybe go back to just a broader question of, in your thesis, you're very opinionated, you have been for a while. What are the edge cases, or where can you be wrong? And what are perhaps the known unknowns as you think about the implementation of something like a full version of a local fee market or whatnot? Like, I'm just kind of curious how you think where this thesis could break today.
Generally, the point of view has been modularity. We need modularity for customization. And for example, if you cannot customize the technical stack enough in a Solana, Sui, Aptos of the world, I have to go create my own app chain, or I have to go create my layer two because I want more control of that. And I think it's, where does more of the value accrue? Like, is it in that 80 to 90% that could fit on a integrated high throughput blockchain, or is that value captured in an L2 or an app chain? Because you need that customization. I think we're really in the early days of kind of the high throughput integrated blockchains, and they will be more customizable over time so that application specific chains are less useful than they may have been in the past.
Hey everyone, wanted to give a big shout out to today's sponsor, Wormhole Foundation, stewards of the Wormhole protocol. If you are like Santi and I and you play around on chain, you know how bad the cross-chain experience is today. Well, Wormhole has set out to solve that, powering cross-chain transfers for over 200 different multi-chain teams, including some of the best like Uniswap and Circle. So what does that mean for you, the Empire listener? This opens up a huge number of multi-chain use cases across DeFi, NFTs, governance, oracles, and more. By supporting over 30 different blockchains and 6 different runtimes, including Sui, Solana, different ETH L2s, Ethereum, and a whole bunch more, that means you have now the most powerful interoperability platform at your fingertips. If you're a developer, you'll be excited to hear that Wormhole provides an extensive suite of tools and infrastructure so that you can securely build multi-chain applications. But don't just take our word for it, obviously. Wormhole protocol leads the industry in all-time messages transferred with over 900 million cross-chain messages. 900 million, that is close to a billion, and that's a big number of messages. As a thank you, Wormhole Foundation is dropping exclusive NFTs. That's right. We got some exclusive NFTs for Empire listeners. Hit the link in the description to claim your unique Wormhole NFT today. The days of not using crypto for really anything in the real world are over. It is time to start using crypto in everyday transactions, whether that's shopping online or just buying a bagel on the street. We're excited to tell you about PYUSD, PayPal's entrance into Web3. PayPal is proud to share an open letter to the crypto community that outlines their commitment, their roadmap, and their goals in the digital currency space. PYUSD seeks to transform how you interact with your digital assets. Available today, you can send your crypto to your PayPal account, swap it for PYUSD, and then use it to check out at millions of stores. PayPal invites you, all the Empire listeners, to be a part of this journey. Hit the link in the description of today's episode to read PayPal's open letter to the community. It gives you a really good sense of what their vision is. Take the next step by signing up for a PayPal account today. The future of crypto payments starts with PayPal. Logan, how do you make bets then at Frictionless? Because you're overwhelmingly excited about Solana, but as a fund, you have to outperform, right? So I'm assuming you can't just buy a bunch of Solana, and you also probably can't just invest in the Solana ecosystem. So when something like Sui or Say or Monad or something comes across your guys' desk, like how do you think about investing in that?
I mean, at Frictionless, most people will bucket us as a Solana fund. I mean, just because we are one of the few funds that was publicly bullish Solana, and obviously we're extremely excited about the Solana ecosystem. But how I like to classify ourselves is as a thesis-driven fund. Like our thesis is that you need high throughput and you need parallelization. Solana was the first to kind of enact that. But that thesis also expands to other high throughput blockchains because some of them are doing interesting things that are different than, say, a Solana. And so Sui is doing interesting things with Move. Aptos is doing this parallel processing optimistically, which maybe engineers are like, hey, this deterministic parallel processing is really sucks. Like, I really like how Aptos is doing that. There are differences between them. They are more minute, as I said, but we're very open minded to the fact that, look, there are a couple 100,000 people that use blockchains today. It's not a couple 100 million. And we need to be open minded from a kind of fun perspective to where users are going to go and where engineers like building. I do think Move is a very interesting programming language that was specifically designed for blockchains that could potentially be the most dominant programming language in the future. So maybe that's Sui, maybe that's Aptos. Solana can also ultimately compile Move down to LLVM. So Solana is really program agnostic, but there's different trade-offs.
Yeah. We've talked a lot about engineering components and physics of these
Yeah.
blockchains. Anything else that is, before we transition more into the, as Yana was kind of going to, anything else that is worthy of talking at the physics level, at the kind of, distinctions between these high throughput L1s that you think is noteworthy? I mean, I appreciate we haven't talked about so many other things like consent, how they reach consensus and a lot of other things, but I'm curious if there would be anything else you'd call out.
I used to think consensus was more important. Now I think it's less of an importance. I mean, obviously you need to agree on what state transitions happened, but I think generally they kind of are all in the same vein. Um, I I think people do not understand though generally the different levels of performance that these systems are compared to the low throughput blockchains. Even Celestia today is not very high throughput. It's still catching up to these high throughput blockchains like Solana, and it has a long way to go to do that.
Mhm.
So I think the narratives are just narratives, which is fine. Like we're moving in the correct direction. Like blockchains do need to transition from dial up to broadband. And after that, they'll have to go from broadband to fiber optics. But people
Mhm.
do not understand the state of how far advanced these high throughput blockchains are compared to a Celestia or an Ethereum of the world.
Yeah. On this point, I just want to get your takes on a few things. And the criticisms that we hear about Solana are pretty dated, and the chain has come a long way in a short period of time. I think maybe the more general question is: we hear it's not sufficiently decentralized. It's been shut down. Like we see these memes, SBF turning off the chain, turning it back on. What would you say to those criticisms and others in terms of the Solana specifically, and then maybe get your take on some of the other ones, high throughput chains?
So again, I kind of view this very much from an engineering lens in two buckets. One is how many replicas of the state exists. In Ethereum, people often misquote the amount of people that are staking 32 ETH. That is not really representative of how many copies of the ledger exist. Last time I looked, Ethereum generally bounces between 4,000 full nodes and 6,000. Solana today has about 3,000 full nodes. So anywhere from like say 75% to 50% of like full node decentralization. I'm very curious though to see where the market ultimately ends up determining how many nodes is sufficient for decentralization. Uh, Sui has 100. Aptos, I think, is around that 100-ish as well. Say is around 39-ish. So will the market say, hey, that's fine, or will these need to further decentralize? Because Celestia uses Tendermint. Tendermint has an upper bound of how many full nodes you can apply to the network. That's 200. So I think Celestia doesn't have very many full nodes either. So Solana is much more decentralized than a Celestia. It's much more decentralized than these other high throughput blockchains. And I think that will probably continue. I think what people ultimately will care about more is that real time censorship resistance, the Nakamoto coefficient. So the number of independent parties that are needed to collude to stop the network from achieving consensus. And Solana, again, here is relatively decentralized. I think it's like 22 independent validators. Aptos is 18. I think Sui was somewhere around there as well at like 16 or 14. But that real time censorship resistance just means like no single party can stop you from getting an MEV trade. Like that is very important for traders and DeFi. And this is a fundamental limitation of the current uh, layer two landscape because you have one sequencer and one party that theoretically could censor you if they don't like you. Obviously, you have that escape hatch generally, but you're paying so much money and you kind of have this like delayed time that you would actually go to the layer one and you probably miss your opportunity anyways. So that real time censorship resistance piece, I think, is probably what people are going to care about longer term after you get sufficient decentralization, which TBD what the market decides there.
Yeah. The criticism around just quickly on the cost of running these validators is something that we keep hearing on Solana. It has a higher hardware requirement.
Yep.
Of course, there are three different cost buckets as we think about like long term. Okay, you can certainly process more transactions. You have storage costs, you have broadband costs, and you have the hardware costs. Can you just quickly run us through kind of how you think those three components will evolve over time for something like Solana and maybe just other chains?
I think once you transition from low throughput to high throughput, the biggest costs ultimately will be the bandwidth costs. So, how much it actually costs to propagate these networks, propagate the blocks to all the nodes in the network. When you go from today, like kilobytes ultimately to gigabytes, you're sending a lot of data. Like in, I think Solana's docs and their, or it may have even been in their white paper, the once they're doing 1 gigabit per second consistently for a year, it's 4 petabytes of data. So 4,000 terabytes. That is a lot of data. So there are going to be like real world hardware costs associated with that. But I think the biggest cost will ultimately be the bandwidth costs in these networks. What we'll probably see happen long term is that node operators move to locations that have the cheapest cost of bandwidth because it will be a large part of trying to reduce their overall costs to maximize the profit that they're making from the network. The difference is in these high throughput systems, and what like you'll ultimately boil down the conversation to in these decentralizations debates is how much should the hardware cost? Ethereum, obviously there's incredibly smart people, some of the brightest minds in the industry. I think honestly where they went astray was optimizing for low hardware requirements. So being able to run on a Raspberry Pi, being able to run on low internet connections. If you have to do these things, if you have to eventually have higher compute, it's fine to move that to a layer two, but you're still like, you're centralized by that single sequencer at that point. And so you're always, in my opinion, bottlenecked by the weakest link. And so I think being able to have kind of these various costs, if you want to really increase, if you're only increasing cost by 10x, but you're increasing performance by 1,000x, to me that's like a worthwhile trade-off.
Yeah, definitely. I think that's where I've certainly, it took me a while to really appreciate that what makes Solana, I think, superior is you overcome the initial idea that it will cost you $3,000 instead of 30 to
Yeah.
pony up initially to run, but the economics will be far greater if you believe that there is uh, orders of magnitude increase in demand for block space, and the economics for running a validator will be superior, I think. But this is where I want to get your opinion, because you do see the argument of one, I think, uh, like, should Solana implement something like EIP 1559 mechanism? Our fees, like the margin's pretty high, I think, today, but
Yeah.
like the current state of the fee markets in Solana is not perfect. I think I've heard, and I totally say this, I think most people would agree with that. I am curious, like fees are extremely low, and you need to believe that demand like is far greater than it is today to be like probably as economically profitable than in Ethereum.
Yep.
Ethereum is just a really expensive luxury chain. That is not, I hear you, it's not like necessarily viable long term, but in its current state, I'm just curious how you think about the economics of these chains and the sustainability of it. And if at some point we're going to have to see an increase in fees in Solana, or just a better pricing mechanism of these resources to make, because if you don't if the validator, you're ultimately competing for mindshare of validators in a
Yeah.
system, and if they can be more profitable, going to another chain, then that's a bit of an issue, right? So I'm just curious how
I
you think
agree.
about
I mean,
all that.
how I kind of think about Ethereum today is it's like, I think the Jeff Bezos saying is like, your margin is my opportunity. And when I think about Ethereum, they've optimized for like their margins, and they have crazy margins on block space. If you think block space is that product that blockchains are selling, then Ethereum is killing. Like they're selling crazy
Yeah.
expensive block space. But that being said, they have not optimized for scale. And so this is where the high throughput blockchains have ultimately taken the other side and said, we will optimize for scale first. And then if we hit scale, then the economics will start to make sense because you're doing much more transactions, but they're at a smaller amount. So today, I think Solana's inflation and other blockchains or high throughput blockchains is around 7%, 6 to 8%, somewhere in that time frame. For Solana specifically, the goal is to get inflation down to 1.5% a year. But to offset the validator costs, really there's three main components. One is just increased network activity. I think we put a blog about this post FTX on Frictionless website, running these numbers. Solana had to increase like network traffic like 11x or something to get to profitability. That's just like purely off network traffic. So you can either increase network traffic, so more transactions on the network, increase priority fees, where you want to pay more to access a state because you want
Because it can be
you want access to that state before other people. And then the last one is MEV in these like hotspots and like redistribution of MEV. So I think everybody likes to criticize high throughput blockchains today because they are inflationary, but they just really haven't had, in my point of view, the amount of time in the market that Ethereum has. And people like to forget. Like, I mean, Solana only came out in 2022. Aptos and Sui launched last year. So, like, these are relatively new ecosystems. Like, Monad's not even live. Celestia just started.
Mhm.
So, I think it will just take some time for these networks to mature and to actually hit scale. But the key difference is they can actually hit scale where unless the community really wants to change the hardware requirements for Ethereum, I think it's going to be much harder for them to actually hit scale.
Yeah, absolutely. Um, Maybe a last question before we transition into just some of the topics or applications that you're really excited, like only possible in Solana or some other ecosystem. Um, like, what do you think is the biggest challenge or problem of Solana today? And I pick on Solana because it's the farthest ahead, and I think it's gotten
Yeah.
a ton of attention, and you followed it quite a bit.
Um, I mean, Anatoly recently has been talking about. So you can think of a blockchain as like scaling the rights. Like if and what I mean by this is if I post to Instagram, that's a one write to a database. But the reads, like people that are viewing this content, you could have 100 people swipe by that Instagram post and 100 people view it. So you have one write, but 100 reads. And you can kind of think of the RPCs as the reads for these networks. Um, just making sure that RPCs are good, also scaling. It's kind of like once you go from a low throughput blockchain to a high throughput blockchain, you also have to optimize everything else in the stack to be high throughput. The oracles, obviously, you have to scale the computation, the RPCs. Like it's not just one thing; it's the entire stack that has to go from kind of this old architecture to a new architecture. And I think Solana, particularly, is just kind of hitting that their stride now. Um, Maybe downsides, I don't know. Obviously, if the network goes offline, that's horrible. They've been doing a very good job about optimizing the network for uptime. FireDancer will add additional
More
redundancies on the
redundancy.
client side. um, but it's hard for me to articulate, and that's why like I'm very bullish, but I try to talk with a lot of people to tell me where I'm wrong, because you're always going to be some degree wrong. You just try to be less over time.
This is why I've tried to open source my thinking and just being more vocal. Of course,
Yeah.
I've followed Solana for years, but just want to make sure that I'm not missing anything. And from all kinds of different players in the ecosystem, builders, investors, I think most people are still very underweight this idea that it's still very much an MEV, like sorry, EVM centric world.
Yeah.
Um, so that probably changes. So maybe
And I think
transitioning. Go ahead.
I think this is where like the podcast is extreme alpha. I mean, going back to your point, Jason, like when I first met you, I was literally starting my podcast and trying to get people to
Yeah.
talk to me like yourself in New York. But that has really been one of the best sounding boards for me, is just talking with extremely smart people and seeing where their views differ and how the industry is going to scale. Most VCs
Yeah.
I've learned don't read white papers, let alone talk to the engineers.
Logan, are there any folks who you've had on the podcast who you've been remarkably impressed by? Like any founders, any investors who've kind of blown
Um,
you away?
I mean, I I think Shram is very smart from Eigenlayer. Him and I were DMing, talking about different things that they're working on EigenDA. I think I am interested to see what Shram pulls up. To me,
Yeah.
he always can kind of pull a rabbit out of the hat. Obviously, Anatoly has been really steadfast in his vision. I really admire the founders and the investors that don't waver. I mean, you should change your mind if you find better information. That's like a part in my mind of like being either a good investor or a good builder. Like if someone's able to articulate things to you that are much deeper than you have really put thought to it, and they can invalidate your thesis, it's kind of immature in my mind to continue to hold that point of view. Anatoly has obviously done an amazing job at like being pretty steadfast, and he's never really wavered in terms of like, hey, I want to synchronize state at the as fast as possible. Sam Blackshear, the founder and CTO of Sui, very smart. I did a podcast with him. I believe the first podcast with him in Palo Alto when they were launching. Sam's level of depth on the engineering, I was just very
Yeah.
surprised by, which I shouldn't be, but very smart. Had great conversations with Avery. Um, Generally, I would say those people. Now I'm interested in engineers, though, actually building applications, because to me, as much as I love this stuff and like love the infrastructure talks, they're kind of like a means to an end. Like it's
Yeah.
dumb to me that we're having this conversation in 2024 when I don't know how long the industry has been around and we still haven't hit scale, and we're talking about infrastructure because it doesn't scale. Like I want applications that actually hit mass adoption, and that's
Let's
what
go.
I'm excited about at Frictionless.
Yeah, let's go there. What are the kind of buckets of applications that you're most excited about? And I think as Santi was asking before, like what are the applications that get uniquely unlocked by this whole last hour of infrastructure conversation that we've had?
I mean, the cliche one is like order books. I mean, AMMs were really birthed from the limitations of having a blockchain that can only do 12 transactions per second. I think it's been interesting how kind of say Uniswap has continued to evolve. It's starting to look more and more like an order book, um, but it's still not an order book on chain. I think there's obviously always going to be place for AMMs in the world. They help bootstrap liquidity, kind of get that 0 to 1 moment flywheel for tokens to get started. But for real price discovery for larger trades, I think order books just make sense. And that is uniquely enabled by a high throughput blockchain when you're going from 12 transactions per second to 500 to 1,000 transactions per second, and even more. Um, and that I would say that, like broadly, is one very interesting kind of point that's only really possible on a high throughput blockchain per se. Um, what else? I'm
What
very
about
interested
perks
though.
like higher frequency DeFi applications?
You can kind
Um,
of think of MEV as like arbitrage between time that has passed in the world. And the longer the block times are, and like the less you're updating your worldview, the larger the MEV events happen. So like Flashbots has made a shit ton of money because the block times in Ethereum are really slow. And there's a lot of arbitrage because a lot of things happen within that block time. And so when you are able to reduce block times to a second, to 400 milliseconds, to 200 milliseconds, to 100 milliseconds, less happens in the world. And so you're more kind of trading on noise than anything else. And you generally kind of reduce MEV between each block. There's a lot of kind of like small examples like that. I think one thing that I'm more excited about, though, outside of DeFi, is just these decentralized physical infrastructure networks. They're very, I like them because you can reason about them. You can kind of extrapolate them where like a Hive Mapper or Helium of the world, you really don't need that many people kind of setting up the hotspots or driving around the world where you can see this like actually compound in a pretty meaningful way. I think being able to go into the world and physically do things is a little bit more challenging than kind of the what I call the digital commodities of DePIN, which is like bandwidth, compute, and storage. I like that just because it's more passive. But I think both of those are uniquely enabled by high throughput blockchains, and they're much harder to do on low throughput blockchains.
One of the things we haven't talked about is this coordination. I think ultimately, as I think about blockchains, are just could be really interesting instruments to improve coordination through better incentives. Helium is a good example. I actually passed on the seed because I felt that this was had been tried before and then without like crypto incentives, and then here we are. The risk I see there, of course, is that telcos come in and really make their business difficult. How do you think about when atoms meet bits in some of these kind of applications? People talk about as another example, real world assets bringing a lot of supply and inventory from the real world into a digitally native context, and that has a lot of a whole host of issues that I don't think are impossible to overcome. But I'm curious to get your thoughts on those applications because in some ways, DePIN makes that crosses that chasm, if you will.
I think the atoms part is harder to coordinate, but that is what generally the token is trying to incentivize people to do. And I'm curious with Hive Mapper, with Helium, if they can reach a sufficient level of scale, I think they're going to have a pretty insane moat because it's just hard to coordinate people to do things in the real world. It's if you set up a hotspot for Helium in Miami versus New York, those are fundamentally different places, and it's hard for generally most people to set up in hotspots in both locations. That could be a moat because it's hard to replicate. I think on the flip side, the digital commodities of DePIN, the bandwidth, the compute, the storage networks, those probably can scale much harder, at least in the short term, because in general, you have kind of one click deployment on your computer saying, if I have additional hardware capacity here, rent it out. I'll earn $5, $10 a day, whatever it may be. And I don't really think about it. I didn't really have to do that much in the physical world. I already have those resources at my disposal, and I'm just letting other people use them. So I think from that standpoint, on the short term, those are likely to scale much harder. I'm curious though how defensible those will be as they continue to scale because they are kind of easier to bootstrap.
Are there a certain type of application or projects that you will not invest in?
There's a lot. I mean, I I I generally there's this really cool Mark Andreessen post from a long time on his blog post that kind of articulates from a venture perspective how you should think about kind of product, team, and market. And from that blog post, he uniquely talked about how you, at least from a venture side, you should focus most exclusively on the market and how large the market is going to become instead of the product and team, which I think if you talk with most VCs, they'll say, it's the team, the team, the team, which obviously the founding team is very important. They need to have the skill sets, but a good entrepreneur building a good product in a small market is still going to have a small outcome. And so for us, I think we uniquely focus a lot on how big markets are going to become and focusing on areas within there instead of like only focus on the the product or only focusing on the team. The market matters quite substantially. Even a mediocre team, mediocre product, where the market is compounding at like 50% year over year. To be honest, most of crypto, you can have a lot of mistakes be forgiven because the market's growing so
Mhm.
quickly.
A lot of the dollars have been historically allocated to infrastructure. The market
Yep.
just has a clear conviction that it could be $1 billion. I'll probably take any infrastructure bet with a good team, sub 50 million, because I think I see a cleaner path to a 10, 20x than, something like a front end. I believe that will change
Yep.
largely a lot of the things we've discussed here because you finally have the possibility to scale these things. As you think about where you allocate your dollars in some sort of ratio, infrastructure, middleware, front-facing apps, SoFi, deep in, whatever you want to call them. How do you think about that trade-off? And today, if you had $100 million to deploy, or
Mm,
$100, it's really the same
I,
calculus, I think.
I think the current high throughput blockchains are probably going to still be the winners in like 5 or 10 years time frame. I have a very hard time seeing how they get displaced. I think generally infrastructure bets just for like say doing a Solana in Europe or Asia markets or like doing application like L1s to our specific geographies probably not going to do well. And I think we truly are at the precipice of transitioning from infrastructure investing to application investing. And there's going to be a lot of investors that are caught off sides because they have not done their homework and understanding how big of a difference these high throughput chains are from the low throughput blockchains and where applications, what type of applications are uniquely enabled on high throughput blockchains. I think a lot of people are going to be
Yeah.
caught off sides. We're going to be focused predominantly on like the application stack, but generally kind of agnostic if a awesome market exists and great
Mhm.
entrepreneurs are going after it.
Yeah. I mean, I think you guys are big investors in Backpack, which is one of the top projects in Solana. Maybe that would be a good example of walking us through your thesis there, because I'm curious and trying to get at value accrual, right? Because I see no reason why Solana can't be as big as Ethereum from a market cap perspective, and then just grow from there.
Spicy take,
At the
it
very,
could surpass it.
I don't think it is, candidly. I mean, that is more of an assumption, not necessarily that Ethereum goes down much. It's just that Solana is just meaningfully, from a technical architectural standpoint. Like I just don't think
Yeah.
there's. Anyways, none of this financial advice. But I'm curious.
Disclosures.
You know, I'm curious. Like maybe Backpack is an example. Like, how do you think about the relative trade between investing in Backpack? You have illiquidity. You're betting on a team. There's more risks there, like specific to them versus just investing in the L1 token of like just buying Sol.
It's a good question. I mean, particularly with Backpack, we were very impressed by their ability. I think when we kind of went down the exchange rabbit hole, what we ultimately found, it's very hard to obtain licenses. So just literally getting to the starting line and being able to operate in key jurisdictions around the world is very hard. It is not easy to get those licenses. And when we were looking at just how large kind of crypto adoption is today, it's still relatively small. Maybe a couple million people hold crypto. One of the estimates I saw was 500 million people hold crypto. To me, that seemed optimistic, but there's really maybe few 100 million people, 10 million people that have ever interacted with blockchains at least once. And so our thesis there was really, will blockchain adoption continue to grow? And if so, will you need kind of a global player to help, one, with kind of the more centralized trading, but more importantly, the fiat on ramps and off ramps into these ecosystems? And I think Coinbase has obviously done a fabulous job with the US market holding down the fort there. They've been a little bit slower on the international markets. Binance obviously is a massive gorilla internationally, but perhaps cut some corners with the licensing to be able to um, cutting some corners and just in terms of how they approach different markets, and now are getting their licenses revoked in some jurisdictions. And so we really thought if Backpack can become a large kind of player in the ecosystem, get a lot of market share, I think there is a huge opportunity for just the crypto ecosystem to grow, and having a kind of compliant exchange from day one that's playing by the rules, facilitating the on and off ramps between kind of the crypto rails and traditional banking providers, I think is going to be extremely valuable.
Yeah. Well, look, I think this has been a fascinating discussion. We could go hours and hours on decomposing more specific elements of these blockchains. I think we're probably should do an episode later on this year. Um, I would love to just maybe do a quick set of questions,
Sure.
if you're okay with that. Oh, Yano, I don't
Yeah.
know if you have any other questions around just more stuff,
And
but I guess like,
tell me where I'm wrong too. Like, where do you think? I know. Uh, you, I mean, I'm always open to it. I think I want to learn just as much as like I hold my opinion strongly. Like, I could be wrong, but
mhm,
I've done a lot of homework in this. And I mean, as I've said, like I've been trying to disprove this thesis for the last 2 years. Since we first met Yano, like my thesis has not really changed because I haven't found new information to like discredit the point of view that I hold, but I always look for it. So I'm very open minded. I just want the industry to
mhm.
actually hit meaningful levels of scale. And I've been saddened by that hasn't been the case yet.
I don't think you're wrong, Logan. I think what's going to probably happen is some of the problems that Ethereum encountered, Solana is going to encounter and is going to have to deal with. Things like governance, things like maybe there's going to have to be its own version of 1559 on
Mhm.
Solana. Like things like that feel pretty inevitable. And if Solana, Ethereum was already so hardened as a community that the tech stack became very hardened. And if the mindset of folks in Solana also get very hardened, they're not going to be able to, when someone like, let's say, Sui builds something that's 5 times more efficient and 5 times easier to build on. I'm not saying that about Sui, but I'm making that up. But Solana needs to be able to adapt to that. So
I
that's the
agree.
only, that would be
Yeah,
like
I
the
mean,
why you could be wrong.
I think if anything,
yeah,
we've seen that maxis kind of do not win long term, and
Yeah.
like, and that's why like our fund, like I say, we're a thesis driven fund. Like we have had the kind of idea that parallel processing is going to be a requirement because you have localized fees, and ultimately you'll have to continue to scale throughput. And other than that, we're kind of open minded to how we get there. I just want scale. I want the industry
yeah.
to be more impactful than what it is, because I truly think this technology is the one of the coolest things that's happening in the world. And I'm saddened by the fact that it's only in the hands of few people. If we really get back to like banking the unbanked, which was the original vision that got me in, like I would be super excited.
Yeah, I would agree there. And both what you guys said. I mean, ultimately, I think it will become more apparent of the have and have nots because as you finally start getting applications, hopefully, that are non-speculative per se, just more like, referral networks, or just like putting a lot of these type of programs on chain and really battle testing, not purely from a security standpoint, but also from a scalability standpoint. I think it will become more and more clear for everyone in the ecosystem, all the stakeholders, users, and also builders, of what's a viable, chain to build on. And so I think ultimately, like, we've been in this state for like L1 loyalty, which is going to be largely irrelevant when you onboard billions of people. They will not care about, your bias towards a particular L1 or your bags. They'll go where they can do stuff faster, better, cheaper. And it's already starting to manifest itself in user activity. And you look at Jupiter, you look at Tensor. I mean, it's just, you're seeing that. And I guess I've often thought about, well, you kind of saw that with Binance Smart Chain. Like at one point, everyone went there and traded in PancakeSwap, and it sort of like was, for albeit briefly, more popular AMM than Uniswap. But then that kind of went away, and I think it just like I think it is different. Like the Solana and the security, the trust, like the caliber of the team, and so in many ways, like Binance Smart Chain was an implementation of Tendermint, which but
I think,
but yeah, I generally think users don't care about security or decentralization. They care about,
and those
ultimately,
things do matter. It's just like how
Oh,
much
no, of
do
course.
they matter, and then like once you get sufficient decentralization. Haseeb from Dragonfly actually had a great like blog post on this, which I think it was like called "Sufficient Decentralization," where once you get to a certain point, you really get like diminishing like returns if you continue to decentralize. And I think, to your point, Santi, new users, they don't care about these different ecosystems. They want the one that they can use. And that's why it got me really excited when I saw just even the NFT stuff going on in Solana kind of last bull market, is because those were the people that were priced out of doing things on Ethereum. Like they wanted to do probably NFTs on Ethereum. They just couldn't because gas was so expensive. And I think the more that we can get people just trying things on chain and participating, that's what gets me excited. I think the people that have allegiance to Ethereum are the people that made Ethereum. The people that have allegiance to Ethereum, they often got rich by Ethereum and they continue to champion that. The new users have not made money off Ethereum and are not as much as biased.
Yeah, absolutely. Maybe a parting question, just one, which is what is, in your journey in crypto, what is something that has surprised you the most?
The cliche thing is all the frauds. I think, I mean, but maybe more a personal one. I think one of the sayings is like, you can make friends or you can make money. Like, do you want to be right or do you want to make money? I think I've had to learn, especially because I've not really changed my point of view just on high throughput blockchains really since like I started my blockchain journey. It was very hard for me to be comfortable with kind of taking the opposite side of what majority of people think. It's not exactly fun. Like if you go to a party and you're like, hey, I'm not bullish Ethereum for XYZ and reasons, and here are all the reasons why I think you're wrong, you're not very popular at parties. And I think for me, what I've really come to appreciate is just like, it's okay to not be the most popular person. At the end of the day, my job is to make LPs money and to be okay kind of in your skin and voicing kind of different points of view in the market. It's not always fun, but I think that advances the space and moves us forward and kind of breaks us out of that echo chamber.
Yeah, that's well said. I mean, crypto is still very much non-consensus. So we're here talking about like different factions within a very much non-consensus trade of our generation, of our lifetime. But no, I hear you. It can be very difficult at times when you get that criticism. But ultimately, you're in the pursuit of truth and being right.
True. Investing is, to me, it's finding the truth and then manifesting the investments through truth. You have to find it before other people. And to me, it's like the ultimate puzzle, which I like from my over engineering brain.
Nice. Logan, a true pleasure. Obviously, I'm excited about what you guys are building. Potentially will invest in the fund. So, there is bias here in these questions. But I do remember the first conversations that I had with you. We spoke one day, and then very quickly the following day, I spoke with you because I found you to be really deep in the tech, have a very, very fine appreciation to the point that you're able to talk to founders like Anatoly and the founders of all these other blockchains. I very quickly reach my limitation within a matter of seconds. You are able to carry a conversation with them, and it's very apparent. People should go check out your podcast because I think that is a public good that has helped me personally understand a lot of these projects that perhaps I was an investor in, or a lot of them I am an investor in, but I haven't had that level of appreciation. And I think so definitely would encourage people to go listen to that if you want to get deep in the weeds of the technical stuff, because ultimately I do think that the best tech will win, even though we constantly go back to these VHS Betamax, like marketing is important, but tech here is like things when they break in crypto, it's not fun and you can't really fake it. Maybe you've gotten away with it over the last 12 years or 6 years because we haven't had real consistent stress tests. But now what's really exciting is we're probably going to see these multiple type of applications that it will become very apparent which chains have that tech and which actually don't. So anyways, thank you for coming on and sharing your thought process, your views, and you're really exciting where you guys go.
Thank you. And thank you both to you, Jason and Santiago. I mean, the reason why I started my podcast was to get my foot in the door. And I was always the nerdy person that did not get invited to any of the parties. And I was the one that was just watching your guys' podcasts and your Twitter accounts. And so for me to be here today, I'm just very appreciative. You guys are a great force for the industry, and I appreciate each of you contributing to push the space forward.
Appreciate you, Logan. Congrats on everything, man.
Thank you.
Hey everyone, thanks for tuning in to today's episode. Don't forget to claim your free Wormhole NFT exclusive to Empire listeners. Hit the link in the description of today's episode and fill out the form to claim your unique Wormhole NFT today. Hey everyone, thank you so much for watching today's episode. Really hope you enjoyed it. We wanted to take a second to just remind you about our upcoming Digital Asset Summit in London, March 18th to 20th. Santi and I got your back. Seats are limited. If you heard it earlier in the podcast, there's a little competition running at Blockworks to see who can drive the most number of tickets. So when you register for the Digital Asset Summit, make sure you use our code. See you in London.